Assalamualaikum, my name is Ahmad Ashraf bin Saiful Bahari. Today I will present my final year project and the title is Antibiofilm Activity of Palmitic Acid Against Streptococcus Pneumonia. Streptococcus pneumonia can cause infection in numerous areas of the body, including the lungs, the ears, the sinus, the brain, and the spinal cord tissue, and also in blood. Through coughing and sneezing, this disease can easily spread from an infected person to others. According to World Health Organization (WHO), pneumonia killed about 800,000 children under the age of 5 in 2017, accounting for 50% of all deaths among children under the age of 5. Streptococcus pneumonia is the most common cause of bacterial pneumonia in children. The significance of the study is Streptococcus pneumoniae is an infection pathogen responsible for millions of deaths worldwide. This study shows Palmitic acid antibiofilm protection against Streptococcus pneumoniae. The objective of the study is to evaluate antibiofilm activity of Palmitic acid against Streptococcus pneumoniae and to determine the effect of Palmitic acid against biochemical composition of Streptococcus pneumoniae. Next is literature review. Biofilm producing organisms adhere onto abiotic and biotic surface and are surrounded within the extracellular membrane matrix, which is produced by the bacteria itself. And antibiofilm molecules have been discovered to be effective against various bacterial illness. In reaction to stress and harsh conditions, Streptococcus pneumoniae produce biofilm to aid bacterial survival. The biofilm structure consists of aggregate microbial cells encased in an extracellular matrix of polysaccharide that adhere to surface. The extracellular matrix protect and promote the pathogenicity of Streptococcus pneumoniae. Palmitic acid has shown effectiveness against methicillin-resistant Staphylococcus aureus (MRSA). Specifically, palmitic acid at a concentration of over 1.6 mg per ml inhibit MRSA in vitro, and it inhibits the growth of MRSA in infected cells in vivo. Next is methodology. The first step is preparation and confirmation test. The local isolate was cultured on straight neutral agar, and after incubation, the catalyst test has been conducted for further confirmation. The second step is preparation of test solution. Palmitic acid were used as an antibiofilm, and 2-4 serial dilution has been made to get 6 different concentrations of palmitic acid. Next is nitric well microplate were used for biofilm formation, and after the incubation, plates were air dry and stayed for 10 minutes with 50 microliter of 0.2% crystalline at room temperature. And at 570 nanometer, optical density was determined using microplate reader, and the experiment was repeated 3 times. After that, statistical analysis has been conducted, and the p-value of less than 0.05 will be recognized as statistically significant. After that, seed-well microplate were used for biofilm formation, and sterile polystyrene peroxide were added to each well before incubation. And after that, the biofilm will be scanned using FTIR spectroscopy at range of 400 to 4000 cm. This is the result for catalyst test and understanding. For catalyst test, catalytic enzyme break down hydrogen peroxide to oxygen and water, and catalytic tests were used to differentiate between Streptococcus and Staphylococcus. As we can see, there is no bubble formation, means this bacteria is catalyst negative bacteria. And for gram staining, the observation was made and lancet shaped foci with purple stain has been found, indicating this bacteria. Based on the result obtained, Streptococcus pneumoniae still form poor biofilm at 6 hours. The ring of biofilm become more visible after 12 hours of incubation and remain the same after 18 hours of incubation. After 6 hours of incubation, the sample with 100 microgram per ml is the only sample that have biofilm inhibition, and after 12 hours, all the samples start to show some biofilm inhibition, and after 18 hours, the sample with highest concentration of treatment gave the highest percent of biofilm inhibition, which is 67.13%. The FTIR spectra of Streptococcus pneumoniae biofilm at 6 hours showed a few peaks that correspond to their own functional group. As we can see, the peak at range 600 to 900 is a fingerprint region, and the peak at 800 to 900 is glycosidic linkage. The peak at 1836 is the peak of amide 1, which is in the protein group, and the peak at 3387 is the hydroxy group. As we can see at FDR spectra for 12 hours, there is no longer peak at hydroxide group, and the peak of amide 1 is much smaller. The last one is FDR spectra for 18 hours. As we can see, the peak of amide 1 and amide 2 is almost become flat due to biofilm inhibition. And the peak of polysaccharide, which is abundance of carbohydrate, is much bigger compared to 6 and 12 hours. As a conclusion, this study successfully determined the antibiofilm activity of palmitic acid against Streptococcus pneumoniae, and to determine the effect of palmitic acid against biochemical composition of Streptococcus pneumoniae was successfully achieved. The highest concentration of palmitic acid, the higher percentage of biofilm inhibition, and it was proven in the experiment that palmitic acid is able to inhibit up to 67% of biofilm formation by Streptococcus pneumoniae. And palmitic acid can help to improve infection control and produce new antibiofilm treatment. And as for recommendation, in the future, research may be conducted on palmitic acid due to the ability to inhibit biofilm formation. Due to this study discovering antibiofilm activity of palmitic acid against Streptococcus pneumoniae, and additional investigating might be needed to improve antibiofilm activity of palmitic acid against biofilm produced by bacteria.